Okay, so the next thing we're going to do is using that kinematic start file that we just created, we are now going to make example 1.2 into an AutoCAD version of the sketched version that we had. And these are going to be, AutoCAD versions are going to be always what you hand in for me. For our practice problems, that example 1.1, you will hand in the sketched version of this one. Okay, that's our practice problem for that one. But for example 1.2, you're going to hand in the AutoCAD version, and then for the rest of the examples that we're going to be doing this evening as well. So what I'm going to do is we are going to make this into an AutoCAD. So I'm going to go back over to AutoCAD. I have my Kinematics start file already opened up. Okay, if you're starting AutoCAD, you would open up the Kinematics start file. And now we're simply going to do a file, save as, and I'm going to call it example 1_2. Okay. And now it has a new name. So I'm not writing over, if you would. I'm going to rearrange this and make it in the format that we need it to be. But now I'm not going to be writing over that kinematic start file. Now, as I look at my example 1.2, I'm going to start with my frames, and I'm going to put these two in place. We don't have dimensions in module 1, but in module 2, we'll start having dimensions and such. So as I go back here to AutoCAD, I'm simply going to move. Now, move is going to be these arrows going up and to the right in the modify area. I'm going to click on that, and I'm going to put a box around. I'm going to left click, don't drag, around my frame member. And then I'm going to hit enter. And my base position is going to be kind of down over here, but I'm going to just move it over to the left so it's out of the way of the items that we have there. And then what I'm going to do is I'm going to mirror this so that the frame part is up, just because it's out of the way then of the rest of the mechanism. It's going to be, I'm going to rearrange it the way I drew it here so that my hatching is on the up side instead of the bottom side. So I'm going to go back to AutoCAD, and I'm going to use the mirror command, which is right in the middle of the modify menu here. So I'm going to click on mirror. I'm going to left click and make a box, and then left click again. Don't click and drag. And I'm going to hit enter. And then I'm just going to do a horizontal line. Left click, make sure your ortho is on, do a horizontal line. And then it's going to ask, do I want to erase my source objects? Yes, I do, because I don't want to leave a copy behind. So click yes on there. And now I just flipped my frame member. Okay, if you don't flip it, it's not a huge deal. I just like all that stuff out of the way. And then I'm going to do a copy to the right. So just below the move command there, copy. I'm going to select my frame member again, enter. I'm going to left click and just do a horizontal copy to the right, right about there. Okay. And now these are my two frame members. Okay. Now I'm going to go back underneath here. So I've got my two frame members in place. I'm going to start with my link number 2. So it's going to be straight down and to the right. So I'm going to do the line command. So I'm going to click on the line command. I'm going to do shift right mouse button, go to the center of my frame member. Make sure you grab the center, turn off ortho. And then I realize I'm not on the right layer. That's okay. I'm just going to draw my line going down and to the right. I'm going to hit escape, and then I'm going to reselect it. So if you end up doing this, you just reselect it and then put it on the object line layer. That's all. Okay. And then switch it to object line layer once you have it in place. Now, whatever I'm drawing will be on the object line layer. Now I'm going to draw my handle in place. So I'm going to do my line command again, go on the endpoints here, and I think I'm going to go down something like this. And then I want to be in line horizontal. So I'm going to activate that line horizontally and make my triangle look like something like this. Okay. I'm going to put my pin connections in afterwards. I find it's easier than trying to always go to the centers of each one. Once I have this in place, I can do another line, and I'm going to make my jaw on the end. I've got to go to the center of this one and then kind of out and down. And then that's my moving jaw. Now I'm going to take my pin connection and I'm going to copy that. Okay. My base position is going to be at its center. Okay. And now I'm going to put it at the endpoints of these two items. Okay. All right. So notice that I have pin connections to the frames and then at these 2 points on my handle. The right end of my jaw and the left end of my handle do not have pin connections. Okay. All right. Once I have those in place, now I can do my labeling. Okay. I always do my links first. So I'm going to move my number 1 and the circle. Okay. And I'm going to put it to one of my frame members. Then I'm going to move number 2. And I'm going to put it by my connecting rod. Then I'm going to move my 3 to the handle. And then I'm going to move my 4 to the jaw. Okay. And then I'm going to move my letters to each one of the joints. So I'm going to move A right here, B here. Oopsie, that's a little close. That again. There we go. Then I'm going to do move C and D. Okay. So I have each one of my links identified, 1 through 4, and then I have each one of my joints A through D identified. Now, I am going to add the 2 labels for the special interest points. So I'm going to move X to the end of my handle down here and Y to the end of my jaw. Okay. Now, you'll notice that I have some items left over. I didn't need the slider, and I left behind one of the copies of my joints. All I'm going to do is I'm going to erase those. So I'm going to hit the erase, left click, and window around each one of those items, hit enter, and now I just have my diagram left. Okay. I'm going to do a file save. And it goes actually pretty quick. If you've done a sketch, so you kind of know where things are going to go. And then now that you start with that start file, now you just have to move the items around and copy and, put things where they need to go. The last thing that you can do if you want to is you can add the label of example 1-2 here, but you don't have to. Okay. So we are going to be doing a screenshot or a screen snip of what we see here for our diagram, and we're going to be putting it into a document. So for our practice problems, open up a Word document, just a blank document. And then what you're going to do, make this big. You're going to do a file, save as, and you're going to navigate to where you would save your Module 1 practice problems. So this is going to be in Kinematics and Elements. And so I'm going to call this Mod1 _ practice PR probs. Okay. I'm going to say save. All right. And now I'm going to insert my screen snips for each one of these. Now, I can put example 1.2 either here on my document. So I could say example 1.2, enter. And then I would go back to AutoCAD and I would do my screen snip around what I see here. So the I on mine, a screen snip is going to be Windows Shift S. And then I'm going to put my window, this is a drag window, around the area. Okay. And then I'm going to go back to my window and I'm going to do Control V to paste it in place, or right click paste. Okay. Or if you didn't want to put the example 1.2 here, you could actually add it as a note in your AutoCAD file and then put it around and then just screen snip and put that in place. I just need to know one way or another that that is example 1.2, okay? So if I go back to my Word document, I'm just gonna do a quick save. Oh, no, it automatically did save because it's on auto save. But if you need to, save it. And because then we're going to be adding a couple more here to this document that you'll then upload for your practice problems, okay? So questions on that? Easy peasy, right? Okay. All right. So then I'm going to go back. I use the Windows Shift S. Windows Shift S. Okay, so once I have my example 1.2 in AutoCAD, that's the one, like I said, that you're going to be adding to the Word document. And this is going to be my first practice problem, if you would, in this. All right, so now we're going to continue on in our PowerPoint presentation. So I'm going to go back over here. We're going to go past example 1.1. And now we're going to, or I'm sorry, 1.2. And now we're going to skip ahead to section 1.7, which is mobility. Okay. Now, mobility is going to refer to what we call degrees of freedom. You might have heard this before in terms of engineering and design, but degrees of freedom means it's the number of independent inputs that are required to precisely position all the links of the mechanism with respect to the frame. So basically what I like to say is, how many things do I have to do in order to get my mechanism to function the way it's supposed to? Okay. So as we look here to calculate the degrees of freedom, we are going to use something called Grubler's equation. Grubler's equation. So degrees of freedom is going to have the variable capital F. So F is going to be equal to 3 times n. Lowercase n down here says that's the number of links in my mechanism. Hence the reason we have been numbering the number of links that are in our mechanism. So if you put the number 4 as your highest number with a circle around it, that means that there's 4 links in your mechanism, okay? And that's including the frame, okay? Then you're going to subtract 1 and you're going to say minus 2 times JP. That's going to be primary joints, okay? Primary joints are either going to be pins or sliding joints, okay? Those two. And then minus any higher order joints, which would be cams, gears, chains. But as I told you earlier, we aren't going to address those items until later in the course. So really, we can truncate this equation by not worrying about the JH, because that's really going to be minus 0. So we're going to stop it at 3n minus 1 minus 2 times JP, okay? Which is worrying about just the links and just the primary joints, okay? Now, once we calculate the degrees of freedom, not a hard equation to do. We will get practice on that in a little bit. We're going to get a number. Okay, and as I said, that number is going to equate to how many things I have to do in order to position my mechanism, functionally. So if I get a 1 as my degrees of freedom, that means that I'm called what we call a constrained mechanism. Okay, that's the best case scenario. That is when I only have to do one thing in order to accomplish the task of the mechanism. So in the case, for instance, of the toggle clamp that we looked at earlier, I just had to move that handle and the clamp would do its thing on the other side. Okay, that's a 1 degree of freedom. All right. When I looked at my vice grips, okay, in terms of keeping that top portion locked down as my frame, I only had to move my handle and my jaw would do what it's supposed to do. Okay, so that's a 1 degree of freedom. In many cases, when we look at mechanisms, we already kind of know how many degrees of freedom are there. But what's nice about Grubler's equation and calculated mobility, it kind of confirms that you appropriately identified however many links there were and however many joints there were, okay? If you get something other than what you know to be the number of degrees of freedom, then you might have missed something in that process, okay? Now, if we get a locked mechanism, that means that our degrees of freedom are 0. That means I'm not a mechanism, I'm actually a frame. I'm supporting, because if I try to, I'm not moving anything and I get no output. Does that make sense? Okay, so 0 is not going to be a number that we're going to get in kinematics here, all right, because we have mechanisms that we're moving. And then an unconstrained mechanism is when we have more than 1 degrees of freedom. That means I have to do more than one thing in order to get the mechanism to do what it's going to do. So for instance, a crane has a lot of levers that you got to move around in order to get that crane to do what it's going to do. I've never operated a crane before, but I've only seen it. But that's kind of the idea. It's a more complex process that has to occur in order to get it to do what it's going to do. Okay. All right. So 1 is ideal. 0 is locked or a actual support frame. And then more than 1 just means that you have to do more than one thing. Okay. So let's look at example 1.3. We are going to create the kinematic diagram for another version of a toggle clamp. Okay. And then we're going to also calculate the number of degrees of freedom using Grubler's equation. Now, we are going to be creating this one in AutoCAD, but before we do, let's create a sketch of what we believe our kinematic diagram should look like. Now, this example is found on page 9. And so if you wanted to have a better view of the illustration or what the toggle clamp looks like, it's right here, okay? And if you want to look down below, you'll notice that there is the kinematic diagram that the book came up with, okay? But I encourage you to use this, sketch it out. Again, you're not going to be handing in the sketch for this one. We're going to be doing it in AutoCAD, translating it over, but let's kind of just do the sketch first, be sure we have that figured out, and then we'll translate it over to AutoCAD using our start file. So take a couple minutes to sketch that one out. And if you're not exactly sure, peek ahead, but I'm going to be going over it with you in just a second as well, or in a couple minutes. Go ahead and number and letter your links and joints. Now, once you have it kind of sketched out, okay, you'll notice that the book here, when they do their diagram, you'll notice that they have 2 connections to the frame, which equate to these 2 bottom pins right here, okay? Those 2 are not going to move. Don't connect those, all right? They're just 2 separate connections back to the frame, identifying that they're not going to move, okay? Then what you have is, I'm going to call this a little connecting rod, okay, to what would be the handle, okay? So if we look here, here's our little connecting rod, and then here is the handle, all right? On the end of the handle, they put a special interest point, okay? A lot of times we want to know how far that handle is going to be out so that we can see what it's, what we call the throw is going to look like, okay? Then you'll notice out in front on the left-hand side here, connected to the handle is going to be, if you would, the clamp. The only thing they worried about on the clamp was from this pin down to the end of the clamping area. Now that's valid, right? I made mine a little bit different because I felt like, well, there's a lot of clamp in the front here up on top, okay? So I made mine not a triangle, but more of a parallelogram. So down here would be the clamp part, but this would be kind of the top of the clamp so that I represent to me a little bit more clearly, like how much area is this going to swing through when it's actually operating? There might be overhead clearance concerns potentially. Okay. So you as the designer would know if that's important or not. Either one of these is completely acceptable. Okay. This one or that one based on what you know the design criteria to be. All right. So if you made yours more like the book, totally fine. If you're like, oh, it kind of makes sense to do what Kelly did, that's totally fine too. It's two different looks at the same design. All right. Neither one of them is right or wrong or better or worse than the other. It's just thinking about other elements or other variables that you might want to answer through that process. Okay. So I'm going to make mine look like this. All right. If you choose to do that for your example 1.3, that's totally fine or not. Now, what we're going to do is what you'll notice here is I had 1, 2, 3 special interest points. So I had an X, Y, and a Z just because of the nature of how I changed it up a little bit. Okay. And then you'll notice that number 1 is my frame. Number 2 is that connecting rod. 3 was the handle. 4 was my clamp. And then I used A, B, C, and D kind of going around. Okay. All right. Now, we're not handing this in. We're going to now translate this over to AutoCAD. So I'm going to go back to AutoCAD and I'm going to pull up my start file. Okay. I'm going to go back to AutoCAD. I'm going to do a file open and I'm going to go to my Kinematics start. Okay. And right away, before I do anything else, I'm going to do a file, save as, and this one is going to be example 1_3. Okay. And now I can kind of move this around and do what I need to do. Okay. So going back over here, I'm going to start by having 2 frame points. So I'm going to go back to AutoCAD. I'm going to move my 1 frame item, and then I'm going to copy. Okay. I'm going to turn my ortho off, and I'm going to kind of copy and put it, I don't know, down and to the right a little bit-ish, something like that. Or down and to the left, I should say. Okay. Once I have that in position, and I can always move it if I need to, I'm going to go on to my object line layer, line. I'm going to start on the right-hand side there, and I'm really just going to kind of duplicate what I drew out. So I'm going to go to my center here, and I'm going to go up and to the right, then to the left. This is my handle here. There we go. And then I'm going to do a line down to my frame, center. And again, we don't have dimensions, so we don't really know exactly. So proportionally, we're kind of putting this in place. And then I'm going to do from the center point here, kind of down and to the left, up, and then back over here. That's what mine looked like. If you did more the triangle like the book did, that's totally fine too. Okay. So now this is kind of the outline of all my parts. I'm now going to put in the couple joints that I have. So I'm going to do a copy of my pin joint. And I'm going to go from its center. Oh, I've got it already. Shoots. Okay, let me try it again. So I'm going to do a copy. Enter from the center. And then I'm going to go to the endpoint here and here. And then I have the other two from the frame members, so that should be good. Okay. We don't put it on the ends of the handle or the clamp. And then now I'm going to move my numbers and letters. Brooke, why are the two frames staggered instead of in line? I don't know. I thought they looked, I didn't know if they were in line or not. I thought they looked a little shorter than the other. One was a little bit lower. It's open to interpretation. That's up to you. Yep, yep. If we look back underneath, in this illustration, they show it a little shorter. I kind of looked at it. I thought one was lower than the other, but if you put it in line, that's okay, Brooke. No problem. Because again, we're not given dimensions here, so we don't really know for sure, right? We're kind of looking at the illustration and making some assumptions. Okay, and as long as they're reasonable, totally fine. Okay, so now I'm going to move. Put the chat box out here. I'm going to move my number 1, and that's going to be by a frame member. I'm going to move number 2, this one, move number 3 to the handle, and move number 4. And I'll put it like here. Then I'm going to move my A. I'll put it here. Move my B. Move my C. And move the D. That's each one of our joints. And then lastly, I'm going to move my X to the end of my handle. I'm going to put my Y by my clamp. And then I've got to do a copy for a Z. I didn't add a Z on our original start file. And my Z is going to go up here. And I just have to change the letter to Z. Okay. Once we have those in place, I can erase or get rid of the items that I don't need. Zoom, there we go. Then I'm going to do zoom extents. And then I'll do a file save. Any questions? Once you have all the labels and the links and joints all identified, you can now do your screenshot. So Windows Shift S, oops, I didn't, my cursor down here, Windows Shift S, and I'm gonna do a drag over the top. And then I can go back to my Microsoft Word document, enter. This is going to be example 1.3. Okay, and then I can do a Control V, and then this is the kinematic diagram for this one. Okay. Now, the second part of this problem is to calculate the degrees of freedom or the mobility. Okay, so if I go back underneath, and I'm going to go back to my kinematic diagram that I did manually. Underneath here, I am going to add my calculation for right now. And then I'll show you how you can hand it in. So my Grubler's equation is going to be F is equal to, okay? F is equal to, so degrees of freedom is equal to, and the equation in variable form, you always have to identify your equation in variable form first, and then show the work. So the equation is going to be 3 times n minus 1 minus 2jp. Okay. Now, if we look here, n is equal to the number of links. You don't have to draw that, but n is equal to the number of links as a reminder. And jp is equal to the number of joints. Okay. And it's primary joints. And then it would be minus JH for the higher order joints, but we don't have any cams, gears, or chains, okay? So our numbers then are going to be 3 times our number of links are going to be the numbers with the circles around them. So we have 4 numbers. So this is going to be n is equal to 4 minus 1 and then closed parentheses. Okay. Minus 2 times the primary joints. We've got A, B, C, and D. That's 4 primary joints. So it's going to be times 4. So that means F is going to be equal to 9 minus 8, or F is equal to 1. Okay. F is equal to 1. Now, to write that out, you have a couple options. You could hand draw it out like this, take a picture and upload it. All right. If you want to do it all on one piece of paper for the ones that we have to do it for, that's fine. Or what you can do is we can go back to our Word document, and right below 1.3, we can say, probably tab in, F is equal to 3 times n minus 1 minus 2 times JP. Enter. Then you would say F is equal to 3 times 3 minus 1, showing the work, minus 2 times 4. Oopsie, 4. And then you could say F is equal to 1, because I mean, if you don't have to put the 9 minus 8, you can see the numbers are right there. It's not that complicated. And then that would be showing the mobility for that problem. Does that make sense? Okay. That's one way. So you can put it as part of the Word document. The other thing that you can do is if you wanted to add it as text here on your actual AutoCAD file, you could do it there as well and include it in the screenshot then. Okay. So a couple different options there for handing in the mobility equation. Okay. Now, one thing I want to remind you of is when we saw our homework assignment, okay, remember how there was 12 problems, okay? There were 6 diagrams and 6 mobility equations. See how 12 problems is actually 6 problems? So 5 points for the mobility equation and 10 points for the kinematic diagram. All right. So really, I call it 6 problems, not really 12. All right. Makes sense for everybody? So to get the total 15 points, you have to do both of them. Okay. So that's example 1.3. Any questions? These are fun, aren't they? Kind of fun. All right. Let's go back to our PowerPoint. So we're going to look at example 1.4. Okay. Example 1.4 is a can crusher. So if we go underneath to our book, okay, this is going to be found on the following page, page 10. Okay. And this is example 1.4. Okay. 1.4. So in this case, it says that this shows a can crusher. Okay. That sounds familiar. If you guys had me for the last CAD class, right? We did a can crusher project. So this looks familiar. We want to draw the kinematic diagram using the end of the handle, which would be right here, as the point of interest. Also compute the degrees of freedom. Okay, so this is going to be both. Diagram, degrees of freedom. Now, where you want to look at this is you want to look at this from the side view. So yes, the handle has two links, if you would, but we're going to just look at it in one view. All right. So there's going to be one handle, one connecting rod, one block or slider going up and down, and then the frame connections. Okay. Now, as we look here, we want to look at the operation. The L-shaped configuration here is going to be the frame. This is not going to move. Okay. Connected to it and rotating around the point right down here on that pin is going to be our handle. Then it connects to the crushing element, which is the block, with this connecting rod. And then as we look at the slide, the crushing element, the block, is going to be going up and down vertically. So that portion, that block, is going to be a slider. Okay. If you peek ahead to the kinematic diagram that the book did, this is going to be, if you would, that crushing portion. The triangle is going to be your handle. And then connecting back to the frame is that lower right-hand pin connection. Okay. So go ahead and just sketch out, not going to be handing it in, just sketch out what you believe the kinematic diagram is going to look like using, you know, the appropriate labels for both the links and the joints. So as we look at our diagram here, you'll notice that they created a triangle for the handle. And I wanted to show you why they did that, because you might be like, well, why are they doing that? There's not really a special interest point there. And really it's to show that the handle is one continuous part. If we don't add triangle, or if you would thickness, this is going to look like we see here. And so to me, I think it could be easily interpreted as two separate parts, because you've got a line with two endpoints, or two links or joints, I'm sorry, pin joints, but then you have this extended. It looks like this could be a part and this could be a part. Does that make sense? But by adding, if you would, a little bit of thickness, just like they did, now it makes it look like one continuous handle or part. Does that make sense to everybody? Okay. That's why they did that. If you leave it extended, it's not a bad idea, but this is better. This is better. Okay. All right. So this is going to be our handle connecting rod. And then this is going to be the sliding element that does, if you would, the crushing of the can, right? Coming up and down. Now, as we look here at our link designations, number 1 would be the frame. Number 2 would be our handle. 3, that connecting rod. And 4 is going to be the slider. Okay. 4 is going to be the slider. Then when we look at our joint designations, A, first one, B, C is going to be the connecting rod to the pin on the slider. And then don't forget, the slider always has a sliding joint, D, okay, which is the slider to how it's constrained in its direction, in this case, vertically, okay? Whether you put the D down here or up on top does not matter, okay? Either one, but make sure you call out D. Because usually when students don't get a mobility of 1 here, it's usually because they forgot the D, okay? All right, so now we're going to put this in AutoCAD, and you're going to be handing in the AutoCAD one, not the sketch here, okay? So let's go back to AutoCAD. We're going to open up our Kinematics start file, okay? And we're going to rename it right away, save as, and this is going to be example 1_4. This happens to be the last example we're going to do tonight too. So almost there, almost there. Okay, so now all we want to do is we want to make this in AutoCAD. Okay, so I'm going to move my frame member. Now, in this case, if you wanted to rotate this 90 degrees so that the frame is going vertically, you could, but you could also leave it just like this, because whether it's connected down at the bottom or on the side really doesn't make a difference, quite honestly. I'm going to leave mine just like this. Then I am going to move my slider. Okay, I'm going to turn off my ortho. I'm going to move it up right about here-ish, okay? But this one I do need to rotate 90 degrees, okay? And I want this to rotate counterclockwise 90 degrees. So I'm going to do a rotate on my modify menu there. I'm going to select the entire slider, hit enter. And now at the center of my slider, so where's my center? Here we go, right there. I want to rotate this 90 degrees. So I'm just going to put in, because it's asking me at the bottom, what is my specified angle? It's going to be 90, enter. Okay, and now it's vertical. Okay. Now, I don't know if I want this exactly here. I'm going to move this guy maybe down and to the right a little bit. There we go. That's about right. Now I'm going to go on my object line layer, and then I'm going to start drawing from the center here, my handle. So I want my handle to kind of go out over here, have that little bit of thickness, right? Go back to the center. Okay. And then I'm going to have a line going from the center of my slider. And somewhere along here, I'm just going to go nearest. Okay. And it's going to be, I don't know, right about there. Okay. And just make sure it's connected. And then I'm going to go around and I'm going to add, I'm going to copy my joint, and from the center, base point is going to be my center. I'm going to go right there. And I think that's the only joint I need. Yeah, just right there. Okay. Now I'm going to move, and I'm going to add my designations for my links. So I'm going to move my number 1 to where the frame is. I'm going to move my number 2 to my handle, number 3 to my connecting rod, and number 4 to my slider. Then I'm going to move A here, B there, C. Now I don't think I can get it in there, so I'm just going to go like right next to C. And then D, I'm going to move that so it's either here or here. It doesn't really matter. I'll maybe put it here. Okay. All right. Now, my special interest point is going to be the end of my handle. So there's only going to be an X. So I'll move that out here. And now I just have either one of these left over. So I'm going to do an erase on both of those. And now this would be the screen snip that I would do. So I would do my save quick, file, save, and then a Windows Shift S. Shoots, I gotta get my cursor out of the way. Windows Shift S, and then I'm going to put around there. And then I'm going to go over to my Word document, and I would say example 1.4, 0.4, and then I would do Control V to put that in place. Okay, so there's my diagram for 1.4. Any questions on that? Like I said, with that start file, I feel like they end up going pretty quick, which is kind of nice. Okay. I don't have a Y on this one. There's only one point, and then I got rid of it. There's not always, when we look at special interest, number 1, there doesn't have to be any. Okay. The problems and times are going to let us know. And in this one, I believe it said the end of the handle needs to be a special interest point. And there really isn't another one unless You had an idea as a designer, okay? I just identify X and Y as an option, but if there's only one, that's okay. All right. Yeah. Other questions? Okay, so now that I have the diagram done, then the other part of this that I need to do is calculate the mobility. So here again, I'm going to write it out here. You can put it on the CAD file. You can write it out in the Word document, whatever you want to do, but I do want to see it written out. So this would be F is equal to 3 times N minus 1 minus 2 JP. Okay, you have to write out the equation in variable form on every one of these to start things off. Then I'm going to say is equal to 3 times the number of links. So I have 1, 2, 3, 4 links. So this is going to be 4 minus 1 minus 2 times primary joints. A, B, C, D. 4 joints. Okay. So you can see here, this would be 9 minus 8. F is equal to 1. Okay. F is equal to 1. Now again, something you could do. Always check though. You'll notice up here that I had this very same thing, right? Same numbers. It was a 4-bar, what we call a 4-bar mechanism. I can say file copy, and I could put this down underneath here, Control B, and now I have the same equation. I will tell you for your homework, they're not all one. There's going to be one that is not one. Okay. I'm not going to tell you which one, but I don't want you to get too comfortable. All right. I want you to get too comfortable, but you can do that. All right. So now this takes care of both the diagram and the mobility equation. Any questions? Okay. I'm going to file, save this. Now, oopsie, I don't have to. That's right. It automatically saves. Let's go back to our PowerPoint. So that's our example 1-4. Let me zoom out of here a little bit. Now, in the next section here, section 110, it talks about 4-bar mechanisms. We've already been introduced to this, okay? 4-bar mechanism just means that we have 4 links in our mechanism, which has been all of the mechanisms that we've looked at. And I'm going to tell you, about 90% of the mechanisms are 4-bar mechanisms. They're just kind of, they reduce down to that. Now, there are 3 main types. There's a crank rocker, a double crank, and a double rocker, okay? Those are the 3 main types. On page, let's see here, I have the page listed. On page 20 in your book, they show these configurations. The 3 that we see here is a double crank, okay? Double crank just means that your input and your output make a full circle. Both of them do, okay? So as the crank goes around a full circle, the output also goes around a full circle, okay? The next one that we see here is a crank rocker. That means that our input goes around a full circle and our output is going to oscillate or rock back and forth on the output, okay? And then the third main type is going to be a double rocker. So that means that our input rocks or oscillates and our output rocks and oscillates. This is like the toggle clamps that we looked at, okay? The crank rocker is going to be like a piston in a cylinder bore. It's going to be a crank, and then it's going to be a connecting rod, and then the piston is going to go, it doesn't oscillate. That's a slider crank. I can't think of one right now, but we come upon them. So there'll be some that we look at. And then we're going to also see a couple of these. So these are the 3 main types. The 2 other ones that we see down here aren't as, if you would, popular, but this one is going to be a change position. And then this one is a triple rocker. So again, just kind of looking at the elements there. The 4th type of 4-bar mechanism, and we're skipping over example 1-9, is going to be the slider crank mechanism. This one is the piston in a cylinder bore. So you'll notice here that the slider crank, the input is going to go around in a circle and the output is only going to go up and down. Okay, so that's going to be a slider on the output and a crank on the input. Still a 4-bar mechanisms because we have our frame, our crank, our connecting rod, and our slider, but it's kind of a specific kind, okay? Now, as we look at our last slide here, this just kind of looks at and kind of reviews the CAD skills that you need to do the different diagrams that we have here. So when we use CAD, we have to make sure that we know how to create some circles, some lines, copying, pasting, moving, rotating, as we saw, and also doing a little bit of text to make sure that we have the labels that we need. When you're doing your homework from here on out, and the reason that we set up the Kinematics start file is you are now going to do all of your diagrams in CAD, okay? And then when you have to do additional work, like we'll see, like we did the mobility equations, you have a couple options on how to hand that in, whether it's in the Word document, in the CAD file, or if you want to hand draw them and then take a picture of those calculations. So there's options. Yes, Tyler.
What if I don't have access to CAD
from home? Then you have to do your work here. Yeah, if you don't have access to CAD at home, then you'll have to do your work here.
I mean, what if so there's no exception. I can't really make it the neatest, straightest thing ever. You would not accept it.
We'll talk about that later, Tyler. Okay. But yeah, if you have specific questions, I can answer those. But no, I'm requiring CAD. And the reasons for that is it's so much more. And it's not, you know, in this case, when we're just drawing the diagrams, you can make a good case for that. But later on, when we're calculating what the positions are going to be, velocities, accelerations, we need the accuracy that CAD offers us. So yeah. Other questions? Okay. So now you're at a point, since we got through the information and we did all of the practice problems, I just want to go back to our practice problem assignment. So if we click on Module 1 practice problems, you are going to be handing in the 4 examples we went through this evening through our lecture, okay? So the first one was example 1.1. That's a sketched diagram. We did that one by hand. Example 1.2 was just the AutoCAD diagram only. That was the vice grips, okay? But 3 and 4 were the diagram in AutoCAD and the mobility equations for each, okay? So both of them have 2. Now, additionally, I want you to answer these 3 questions. So make sure as part of your Word document, after you're done with example 4 or 1.4, what you're now going to do is you're going to answer those 3 questions. You're going to tell me 2 things that you learned in Module 1, 2 things that you still feel like you need additional practice to gain confidence in, and what do you feel the main objective of Module 1 was, you know, now that you've kind of gone through the whole thing. Okay, one big idea in Module 1, okay? Now, when you submit these, you're going to use AutoCAD for the kinematic diagrams, the ones that we identified above. You're going to show all your work for the mobility equations as demonstrated in class. So I gave you a couple options for handing that in. And then you're going to take a screen snip, or in this case, upload that Word document, which is the easiest thing to do for the practice problems here. Now, remember, this is worth either 0 or 10. I don't grade this as, you know, 8 out of 10, 7 out of 10, anything like that. You either did it the way you were supposed to or you didn't. I'll give you 1 or 2 little things, but after that, once we hit 3 and 4, it's just 0. I'm not giving you, you know, a grade out of 10. All right. So are there any questions on the practice problems right now? Alex? When I'm done, yes. When we're in lab, I can look individually at different assignments if you want me to. But are there any other questions? Okay. All right. So then I will stop the recording here.